500 active connections slammed a 100 connection database limit, and every endpoint returned a 500 error. The root cause? Each serverless function imported a fresh Prisma client with its own connection pool. The article mentions that Prisma 6 deprecates use middleware in favor of extends, but does not show the deprecation warning or how to suppress it. Add warn on deprecation. False to the Prisma client constructor to silence the warning during migration, or use extends as shown. The article mentions Edge runtime support via driver adapters, but does not show a concrete example. Here is how to use @Prisma/adapter_neon with Prisma 6 on the Edge, including the required connection limit and pool timeout settings. The article recommends connection limit equals 1 and pool timeout equals 0 for serverless, but this only works if your database URL is parsed correctly by Prisma. Some connection poolers like PG Bouncer require these parameters to be passed differently. Always verify that the parameters are applied by checking Prisma's logs or using Prisma $connect and inspecting the pool size. Let's break down Prisma ORM best practices with Next.js 16 in 2026, how it works, and the exact mistake behind that failure. Prisma is like a universal translator between your application code and your database. Instead of writing raw SQL, you describe your data model in a schema file, and Prisma generates a JavaScript client that speaks your database's language. Next.js 16 adds a constraint. This translator must stay on the server side, like a backstage crew that never appears on stage. Connection pool exhaustion is the silent killer of production Prisma applications. It happens when your database server runs out of available connections because clients are holding them open longer than necessary or creating too many instances. In a Next.js 16 serverless environment, this is amplified. Every serverless function invocation can create its own Prisma client instance, each with its own connection pool. The most critical pattern in Prisma plus Next.js is client instantiation. In development, hot reload creates a new Prisma client per reload. In production serverless, each invocation cold starts a client. With default pooling, 200 concurrent requests open 1,000 plus connections against a 100 connection limit. The fix is a global Singleton pattern. Instantiate Prisma client once in lib/Prisma TS using global this. Here's the Singleton implementation. We use global this to store the Prisma client instance, so it survives hot reloads in development and is reused across requests in production. We also add with accelerate for global pooling and slow query logging in development. Prisma's default fetches all scalar fields. Use select to fetch only needed columns. The n+1 problem occurs when you fetch a list, then loop and fetch relations individually. One query becomes n+1. At 1,000 posts, that's 1,001 round trips. Fix. Use include for eager loading or transaction for batching independent queries. Here's the n+1 problem and its fix. The bad version fetches all posts, then loops to fetch each author individually. The good version uses include to eager load the author relation in a single query. For independent queries like counts, use transaction to batch them. Prisma offers interactive transactions, callback, and batch transactions, array. Interactive transactions hold locks for the callback duration, never do HTTP calls or heavy computation inside. Serializable isolation provides strongest consistency, but throws serialization errors under contention. You must retry. Here's an interactive transaction with retry logic for serializable isolation. We wrap the transaction in a for loop to retry on serialization failures, P2034. We also set explicit max wait and timeout to avoid hanging connections. Prisma 6 deprecates middleware use. Use extends instead. It creates composable client layers for logging, soft deletes, and row-level security. Extends returns a new client. The original is unchanged. Here's a soft delete extension using extends. It overrides findMany, find first to filter out deleted records, and replaces delete with an update. This is composable. You can chain multiple extensions. Prisma bypasses fetch, so Next.js fetch cache doesn't apply. Next.js 16 stabilizes cache, formerly unstable cache. Layer, React Cache for request deduplication, Next Cache for cross-request persistence, revalidateTag for invalidation. Here's how to cache Prisma queries. Use React Cache to deduplicate within a single request, and Next Cache for cross-request caching with tags and revalidation. After a mutation, call revalidateTag to invalidate the cache. 3 patterns: explicit indexes, enum state machines, audit fields. Prisma doesn't auto-index all FKs. Use UUID v7 or gen random UUID instead of QUID for better index locality at scale. Here's a production-ready schema. Note the explicit indexes on authorid and the composite index on status and publishStat. We use gen random UUID for time-ordered IDs and an enum for post status. Next.js middleware is your gatekeeper. It validates session tokens, checks JWT expiry, and rejects bad actors before they even touch Prisma. Prisma middleware, via extends, handles data-level concerns, soft delete filters, audit logging, encryption of PII fields. Never confuse the two. Here's the separation. Next.js middleware handles auth and never touches Prisma. Prisma extends handles data-level concerns like soft deletes. This keeps concerns clean and avoids race conditions. You reached for queryRawUnsafe because you needed a complex join that Prisma's generated types couldn't express. But you just threw your entire type safety contract out the window. If you absolutely need raw SQL, wrap it in a typed function. The bad version returns unknown, losing type safety. The good version wraps the raw query in a typed function that returns admin with bio. Schema changes break compilation here first. The Next.js hot reload loop will shred your Prisma client like a meat grinder. Every file save spawns a new instance. The global caching trick works, but only if you coerce TypeScript into acknowledging it. Here's the correct Singleton pattern. We use global this to store the instance, and we coerce TypeScript with a type assertion. This ensures one Prisma client per process, surviving hot reloads. Prisma Migrate generates migrations automatically, but automatic doesn't mean safe. In production, auto-generated migrations can drop columns you thought were safe or reorder indexes in ways that kill query performance. Generate the migration SQL locally, review it line by line, and commit it. Use Prisma Migrate dev create only to generate the SQL migration file without applying it. Review, commit, then deploy. This gives you control over column types, indices, and default values. This is the same issue we highlighted at the start. Here's exactly why that happened. The team assumed Prisma client's default connection pooling was sufficient for serverless deployment. They tested with 10 concurrent users locally and saw no issues. But Next.js 16 deployed to Vercel creates a new serverless function invocation for each request during traffic spikes. Each invocation imported a fresh Prisma client instance, opening new connections. The default pool size of numcpus plus 1 meant each function held 5 connections. At 100 plus concurrent functions, the database connection limit was exceeded instantly. Each serverless function created its own Prisma client instance with its own connection pool, quickly exhausting the database connection limit. The fix involved 3 changes. First, we implemented Prisma Accelerate with Accelerate extension, which provides global connection pooling. Second, we added the Singleton pattern with global this caching to ensure only one Prisma client instance per function. Third, we set connection limit equals 1 and pool timeout equals 0 in the database URL, so each function only uses one connection, and Accelerate handles multiplexing. We also added load testing, with 500 concurrent users in CI, to catch this before launch. Without connection limit equals 1, each serverless function opens a default pool of 5 connections. With 100 concurrent functions, that's 500 connections against a 100 connection limit. Always set connection limit equals 1 and pool timeout equals 0 for serverless. Never instantiate Prisma inside a React component or API route handler. Hot reload will create 50+ connections in seconds. Always use the Singleton pattern. This is the N+1 problem. For 1,000 posts, you make 1,001 database round trips. In production with 10K rows, this causes connection pool exhaustion as queries queue up. Missing createMany and deleteMany in tenant extensions caused cross-tenant data leaks in 2024. Audit every operation when building RLS extensions. A news site cached for 1 hour without revalidateTag. Users saw 30-minute-old breaking news. Use tags, not just TTL. Using queryRawUnsafe without a typed wrapper throws away Prisma's type safety. A schema migration that changes a column name will only fail at runtime, not at compile time. Here's how to diagnose common Prisma issues. First, check for multiple Prisma client instances with grep. Verify your database URL includes connection limit equals 1. Enable query logging to find slow queries, and use explain analyze on a production replica to check for missing indexes. Let's run through some common interview questions. How do you prevent connection exhaustion on Versal? Singleton with global this with accelerate, and database URL, connection limit equals 1 and pool timeout equals 0. What's changed for Edge runtime in 2026? Driver adapters, at Prisma/adapter neon, allow Prisma client on Edge. Still use accelerate for pooling. How do you handle serializable transaction failures? Wrap in for loop with 3 retries, catch P 2034, retry with exponential backoff. Keep transactions 50 ms. Why doesn't Next.js fetch cache work for Prisma? Prisma uses direct TCP HTTP, not fetch. Use React cache and Next cache with revalidateTag. And a few frequently asked questions. Can Prisma run on Versal Edge? Yes, use Prisma 6 with a driver adapter like at Prisma/adapter neon and with accelerate. Do I need both connection limit equals 1 and accelerate? Yes. Connection limit prevents per function pools. Accelerate provides global pooling and caching. How do I migrate from use to extends? Replace Prisma, $use, fn with Prisma, define extension. $extends is composable and type safe. What's the best UUID strategy? Use at default, DB generated, gen random UUID, at DB, UUID or UUID v7 for time-ordered IDs. How to share Prisma client in monorepo. Create packages /db with schema. Prisma, set generator output to shared location, export Prisma from that package. Let's recap the key takeaways. Use Singleton plus with accelerate, plus connection limit equals 1 and pool timeout equals 0 for serverless. Extends replaces middleware, migrate now. React cache plus Next cache plus revalidateTag, index foreign keys and filtered columns. Ready to go deeper? Up next. Server actions versus TRPC in 2026, when to use which, then building production-grade AI features in Next.js 16, then how to build your own AI coding assistant with Next.js 16, OpenAI and RAG 2026 stack, and the new T3 stack in 2026. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.